Okay, so this is chapter 10, number 44, the second time I'm trying to do this because first time it went to 10 minutes and 16 seconds. So let's try again. We have a merry-go-round that's driven by Dad. Dad is pushing with a force, and the kids are sitting opposite each other. It starts at rest, and then after 10 seconds it goes to 15 RPM. But I changed that to radians per second, so that's all of this in radians per second. It's got a radius of 2.5 meters. The mass of the disc, the merry-go-round, is 760 kilograms. The mass of each child is 25 kilograms. What is the force that Dad has to push in order to make sure it goes 15 rotations per minute, revolutions per minute? What's the force he needs to apply to get it to that speed within 10 seconds or by 10 seconds? Okay, so this is the if only game. So force we can find if we just have, come on, there you go. All right, torque is force perpendicular to the radius. So once we had torque over the radius, then we have force. Radius is 2.5 meters. Now all we need is the torque. Is also moment of inertia times angular acceleration. Acceleration is change in angular velocity over change in time. So that's the final angular velocity, 1.57 minus 0 divided by 10. Well, if you divide this number by 10, you just move the decimal point over. Okay. So we have that. Now we need to find the moment of inertia. It's a little more tricky, but the moment of inertia for the disk is 1/2 mr squared. Comes out to 2375 kilogram meters squared. I took the mass of the disk, multiplied it by the radius squared, and then took half of that. Okay. The moment of inertia for the child is, well, they're on equal and opposite sides. So essentially the mass of the child times the distance squared, mr squared. That's mass of child 1. And then the second child has the same mass. So really this is just 2m star. And that equals 312.5 kilogram meter squared. Now let's find the torque of each. Torque of the disk is the moment of inertia of the disk times alpha. So that was 373.0641284 meter newtons. And the torque of the child is the moment of inertia of the children times alpha, and that came to 49.0873853. meter newtons. So the torque of the disc, the torque of the children, and what we've done is these two up, 2375 plus 312.5, and multiply that by the acceleration. You should get the same number, but I did it this way. This was probably a longer way. 137 meter newtons. So now we take that and divide it by the force, and we get 168.860 6055 Newton, and sig figs is 1.7 times 10 to the 2 newtons. And how hard Daddy has to push.